Good morning to everyone. I am Rudra Showdri, working as Assistant Professor of Chemistry, PG and Research Department of Chemistry, A.D.M.COLLEGE for Women, Nagapattinam. I am going to talk about learning the periodic table of elements. Concepts explored in this lesson: introducing the periodic table, about increasing atomic number, about the history of periodic table, what is atomic number, atomic mass, element name, element symbol and oxidation number. Organization of the periodic table. What are groups, periods, staircase, metals, non-metals and metalloids. Metals, non-metals and metalloids and its characteristics and examples. Chemical families on the periodic table: alkali metal, alkaline earth metals, halogen, noble gases, transition metals, lanthanides and actinides. Introducing the periodic table. First we see the introduction, the periodic table. Periodic table is a chart that organizes elements according to their increasing atomic numbers and their chemical and physical properties. When was the periodic table developed and who created it? It was developed in 1869. Developed in 1869 by a man named Dmitri Mendeleev, who was a Russian chemist and inventor. In his time, there were only 60 elements discovered, but his periodic table predicted and left room for the future discoveries of elements. What are atoms? Atoms are the simplest and smallest particle composed of protons, electrons and neutrons. The number of protons in the nucleus of an atom is equal to its atomic number. Normally, the number of protons equals the number of electrons. What are protons, neutrons and electrons? A proton is a positively charged particle inside the nucleus. A neutron is a neutral particle also inside the nucleus. An electron is a negatively charged particle that orbits the nucleus. What is atomic number? The total number of protons in the nucleus of an atom gives us the atomic number of that atom. It is represented with the letter caps Z. It is represented with the letter Z. All the atoms of a particular element have the same number of protons and hence the same atomic number. Atoms of different elements have different atomic numbers. Atoms of different elements have different atomic numbers. For example, all carbon atoms have the atomic number of 6, whereas all atoms of oxygen have 8 protons in their nucleus. And another example is a sodium. Sodium are 11 electrons and 11 protons. Thus the atomic number of sodium atom is equal to the number of electrons and protons is 11. What is mass number? The number of protons and neutrons combine to give us the mass number of an atom. The number of protons and the neutrons combine to give us the mass number of an atom. It is represented using the letter A. It is represented using the letter capital A. As both protons and neutrons are present in the nucleus of an atom, they are together called nucleons. For example, an atom of carbon has 6 protons and 6 neutrons. Thus, its mass number is 12. While the number of protons remains the same in all atoms of an element, the number of neutrons can vary. Thus, atoms of the same element can have different mass numbers, and these are called isotopes. The weight of an electron is almost negligible. Thus, the atomic mass of an atom is almost the same as its mass number. What is the periodic table of elements? What is the periodic table of elements? Elements are substances that cannot be broken down. That cannot be broken down any further by chemical means. They are over 100. The periodic table. The periodic table is the arrangement of these elements by increasing atomic number and similar properties. What are the elements? Each element on the periodic table has an atomic number, symbol, element name and average atomic mass. Atomic number. The number of protons found in the nucleus of an atom. The number of protons found in the nucleus of an atom. Average atomic mass. The mass of an atom including the protons, neutrons and electrons. For example, carbon atom. C is the carbon, that is carbon is the name. Capital C is the symbol. 6 is the atomic number. 12.0107 is the average atomic mass. Next, organization of the periodic table. Organization of the periodic table. How is it arranged? How is it arranged? The elements are put into rows by increasing atomic number. The periodic table is arranged in columns and rows. Each column on the periodic table is called a group. Each column on the periodic table is called a group. Each row on the periodic table is called a period. Each row on the periodic table is a group. How many groups are there on the periodic table? How many groups are there on the periodic table? There are 18 groups on the periodic table. The vertical rows are called groups. The vertical rows are called groups and are labeled 1 to 8. How many periods are there on the periodic table? There are 7 periods on the periodic table. The horizontal rows are called periods and are labeled 1 to 7. The red line shows the different periods. The red line shows the different periods and the green line shows the different groups. Can you find the zigzag on the periodic table? Can you find the zigzag on the periodic table? There is a zigzag that separates the periodic table. There is a zigzag that separates the periodic table into two sides. This zigzag also called the staircase. To the left of the staircase, you will find the metals. You will find all the metals. To the right of the staircase, you will find all the non-metals except for the element hydrogen. Except for the element hydrogen, which is a non-metals found on the left side. Directly to either side of the staircase, you will find elements called metalloids. Directly to either side of the staircase, you will find elements called metalloids. There are 8 of these elements. Grouped elements have similarities. Grouped elements have similarities. Elements in the same group have similar properties. Remember, groups are columns. Chemical property. A property used to characterize materials in reactions that change their identity. Example, burning something. Physical property. A characteristic of a substance that can be observed without changing the substance into something else. Without changing the substance into something else. For example, measuring some things, length, color, mass or volume. The major categories of elements are the metals, non-metals and metalloids. Metals. All metals are solids at room temperature except for mercury, which is a liquid. All metals are solids at room temperature except for mercury, which is a liquid. Many metals are lustrous, malleable, ductile, silvery in color and are good conductors of heat and electricity. Non-metals. Most of the non-metals are gases except for bromine, which is a liquid, and 5 non-metals which are solids. These ones are carbon, phosphorus, silicon, sulfur, selenium and iodine. Non-metal elements are either colorless or have various colors. They are not malleable, not ductile, brittle when solid, poor conductors and non-magnetic. Metalloids. Metalloids are all solids at room temperature. They have some properties of both metals and non-metals. They are mostly metallic in appearance, but they are brittle. They are fair electrical conductors. Examples of metals: gold, copper, silver, sodium and magnesium. And examples of metalloids, that is boron, silicon, arsenic, antimony and polonium. And examples of non-metals like nitrogen, oxygen, sulfur, chlorine and neon. Chemical families on the periodic table. Chemical families on the periodic table. Chemical family is a group or column that contains elements with similar properties. Group 1 alkali metals. Group 1 alkali metals. This group of elements are all soft and silver colored solids. They are the most reactive of all the metals. They are the most reactive of all the metals because they have one valency electron. Because they have one valency electron. They each very readily bond with other elements by transferring their valency electron to each become a stable ion, meaning they have a full outer orbital. Example: lithium, sodium, potassium, rubidium, cesium and francium. The bond between the ions creates a new substance called a compound. They are all reactive with water. To prevent contact with water vapor in the air, they are stored in mineral oil. Elements get more reactive as we go down the group. Elements get more reactive as we go down the group. For example, francium is the most reactive. Then group 2 alkaline earth metals. Group 2 alkaline earth metals. Beryllium, magnesium, calcium, strontium, barium and radium. These elements are also all silver colored solids. They are also reactive with water but less than group 1 metals. They are also reactive with water but less than group 1 elements, that is alkali metals. They each have 2 valency electrons. They each have 2 valency electrons. Similar to group 1 elements, they readily bond with other elements. However, in this case, they transfer their 2 valency electrons to become stable ions with full outer orbits. Elements get more reactive. Elements get more reactive as we go down the group. Radium is the most reactive. Several of these elements are important mineral nutrients like calcium. Group 3 to 12 is transition metals. For example, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. These elements contain metals that have the usual properties of metals. Usual properties of metals, that is lustrous, malleable, ductile and electrically conductive. These metals are all found in the solid state. These metals are all found in the solid state except for mercury, which is a liquid at room temperature and pressure. The transition metals contain some of the most commonly known metals. The transition metals contain some of the most commonly known metals. Guess the metal each of these is made from. Guess the metal each of these is made from. Number 1, tungsten is used as a filament. Tungsten is used as a filament in electrical bulb. Second one is titanium is used for aircraft. Mercury. Third one is mercury. Fourth one is gold metal. Fifth one is platinum. Sixth one is iron. And seventh one is silver. And eighth one is copper metal. Next, boron family. These elements are present in group 13. Boron has properties of both metals and non-metals. The rest of the elements in these groups are metals. Carbon family. These elements are present in group 14 like carbon, silicon, germanium, tin, lead and iridium. It contains elements important to life and computers. Carbon is the basic element in all organic compounds. Carbon is the basic element in all organic compounds. Silicon and germanium are important semiconductors. Silicon and germanium are important semiconductors. Next, nitrogen family. These elements are present in group 15. Nitrogen makes up more than 3/4 of our atmosphere. The red tip of matches is made up of phosphorus. The red tip of matches is made up of phosphorus. Next, oxygen family. Oxygen family is also called as chalcogens. It is present in group 16. Oxygen is necessary for respiration. Oxygen is necessary for respiration. Many things that have a bad odor contain sulfur. Group 17 is the halogen family. Halogens family. These groups of elements are all non-metals and are found in all three states. They are the most reactive of the non-metals because they have 7 valency electrons. Halogens become more reactive. Halogens become more reactive as you move up the group. Fluorine is the most reactive. Chlorine is used to keep bacteria out of swimming pools. Noble gases are helium, neon, argon, krypton, xenon and radon. These are non-metals elements or non-metal gases. They do not bond with other elements. They do not bond with other elements because they have full outer orbitals. Because they have full outer orbitals. Since they don't react with other elements, they do not form compounds. Noble gases are also described as inert gases. Noble gases are also described as inert gases. It is used in lighter neon signs. Helium is used to make party balloons float. Next, lanthanides. It is present in 57 to 71. Lanthanide series of chemical elements comprises the 15 metallic chemical elements with atomic number 57 to 71. They are all metals that have been misleadingly labeled rare earth metals in the past. Actinides. Actinide series encompasses the 15 metallic chemical elements with atomic numbers from 89 to 103. 89 to 103. They are metals that are radioactive. They will spontaneously combust in air. Most of the elements are used in everyday life like silver, carbon, helium, silicon, zinc, iron, etc. I hope these elementary ideas about periodic table will be useful for freshers. Thank you.